of iron and many more elements, primarily carbon, that is widely used in construction and other applications. Because of its high tensile strength and low cost, steel's base metal is iron, which is able to take on two crystalline forms. First is allotropic form, body-centered cubic and face-centered cubic. Depending on its temperature, it is interaction of those allotropes with the alloying elements, primarily carbon, the give steel and cast iron their range of unique properties in the body-centered cubic arrangement. There is an iron atom in the center of each cube and is the face-centered cubic. There is one at the center of each of the six faces of the cube. Carbon, other elements and insulations within iron act as hardening agent that prevent the movement of dislocation that otherwise occur in the crystal lattice of iron atom.
Material used for making steel. The ores used in making iron and steel are iron oxides, which are compounds of iron and oxygen. The major iron oxide ores are hematite, which is the most plentiful, limonite, also called brown ore, taconite, and magnetite. A black ore. Magnetite is named for the magnetic property and has the highest iron content, named for the Taconite Mountains in the northeastern United States. Is a low grade but important ore which contain both magnetic and hematite. Iron making furnaces require at least 50% iron content ore for efficient operation. Also, the cost of shipping iron ores from the mine to the smelter can be greatly reduced if the unwanted rock and the other impurities can be removed prior to shipment. This requires that the ores undergo several processes called beneficiation. The process include crushing, screening, tumbling, flotation, and magnetic separation. The refined ore is enriched to over 60% iron by these processes and is often formed into pellets before shipping. Taconite ore powder after beneficiation is mixed with coal dust and a binder and rolled into small balls in a drum where it is then baked to hardness. About 2 tons of unwanted material is removed for each ton of taconite pellets shipped.
Implementation of steel on site. A steel building is a metal structure fabricated with steel for the internal support and for exterior cladding, as opposed to steel formed building which generally use other materials for floors, walls, and external envelope. Steel buildings are used for a variety of purpose, including storage, workspaces, and living accommodation. They are classified into specific types depending on how they are used. Installation of steel. The erection structural steel work consists of assembly of steel components into a frame on site. The process involves lifting and placing component into position, then connecting them together. Generally, this is achieved through bolting, but sometimes site welding is used. The assembled frame need to be aligned before bolting up is completed and the structure handover to the principal contractor.
History of making steel. Ancient steel. Steel was known as antiquity and possibly was produced in bloomeries and crucibles. The earliest known production of steel are pieces of ironware excavated from an archaeological site in Anatolia and are nearly about 4000 years old, dating from 1800 BC. Horek identifies steel weapons like the falsetta in the Iberian Peninsula, while Doric steel was used by Roman military. The reputation of ceramic iron of South India amongst the rest of the world grew considerably. South Indian and Mediterranean sources, including Alexander the Great, recount the presentation and export to the Greeks of 100 talents worth of such steel. Metal production sites in Sri Lanka employed wind furnaces driven by the monsoon winds capable of producing high carbon steel. Large scale wood steel production in the Malikam using crucibles and the carbon sources such as plant Avram occurred by the 6th century BC, the pioneering precursor to modern steel production and metallurgy.